If you're a developer, this video is for you. We are going to focus on the software decisions that led towards what has been characterized as the vulnerability of the decade. Watch to learn how to code with security in mind. Hey, and welcome to Security Bytes, a series of short videos from the GitHub Security Lab aiming towards educating developers about common vulnerabilities in software. Today, we are going to focus on the Log4J vulnerability.
Log4J, which means logging for Java, is a very popular logging library. It's so popular that it exists in millions of systems in the world, either directly or indirectly. This software library is very useful for when things go wrong, which happens all the time in the world of software. Log4Shell, which is the name given to the Log4j vulnerability due to the fact that anyone could open a shell, made the headlines everywhere. This is due to the huge number of systems exposed to remote code execution, which, as we've learned in previous episodes, allows attackers to literally run anything they want on a victim's machine, including malware installation and data stealing. Let's now understand the vulnerability step by step. Log4j allows expression logging. In the first line, we get the logger client, and in the second line, we log the error message. This is done at runtime through the error object plugging its content into the curly braces that represent the string placeholder. As of now, what we've seen is considered standard logging. Let's now look at the software decisions that led towards remote code execution. This is caused by lookups. Lookups is a feature that makes it really easy to inject some common values into the logged messages. For example, you may want to log the value of a given environment variable when an exception occurs. In that case, instead of retrieving the variable programmatically and concatenating this variable into the log message, you can just append it. There are many types of lookups. One of them, the JNDI lookup, allows you to retrieve values from a key value store, both inside and outside your network, using the Java JNDI protocol. Therefore, this lookup type can do way more than string replacements, including outbound connections to arbitrary servers. Specifically, JNDI, which means Java Naming and Directory Interface, allows the storage of Java objects in a remote location that are then streamed to someone's JVM, which is Java's virtual machine, enabling a computer to run Java programs. A good use case for this feature will be a centralized login configuration from a config server that needs to be loaded to a JVM using a JNDI lookup for the purpose of prefixing logs in a specific way. This is a productivity feature. Simply put, if a user controls part of the data that gets logged, he or she gets to choose not only what is logged, but also the ability to use any of the enabled lookups by using the special $curly braces syntax. Giving such an opportunity to the untrusted user has proved a bad software decision, even if there was a legitimate productivity reason behind it. But do the benefits of this use case outweigh every worst case scenario? Let's see this in practice. In the first line, we have an LDAP URL that we can use to acquire Java objects from any LDAP server. Now in line 4, we acquire a prefix for the logging message from the configuration server by passing a JNDI URL as an argument. This will normally be used in the pattern layout, but for the sake of the demo, we will be using it here. The JNDI URL passed above is not malicious, but if a user controls the message returned by error.getMessage, there is nothing stopping him or her from adding another lookup. In that case, a malicious lookup could be performed and malware could be installed in a victim's machine. Take the following example of a search feature where an untrusted user passes the following malicious query. Another attack is one that will send secrets retrieved from environment variables outside to a malicious resource using this search query.
Obviously, updating to a non-vulnerable version is the way forward, but let's focus on the big picture here to avoid similar flaws in the future. This feature was added in 2014, 2 years before the JNDI system was publicly known to be a vector leading to remote code execution, which means that the Log4j maintainers were not aware about the risks at the time. However, security is about looking at the right place with the right security mindset. Even in 2014, Were there any good reasons allowing outbound connections to any arbitrary server in the internet? Security in depth is about adding as many layers as possible to the security cake and assume that some of them will fail. This vulnerability highlights that developers often use libraries blindly without considering all the features they are signing up to. Of course, in practice, it's very hard to review all possible configurations of all dependencies. But the realistic way to reduce the attack surface would be for the Log4j maintainers to make those powerful lookups opt-in. By that, the principle of least privilege will be applied through an approach that is denial by default. Make sure to leave a comment below to let us know about your thoughts on Log4j. In the meantime, follow us on Twitter for our latest updates, and remember, quality code is secure code.